everybody. Okay, the relays came in today. This will be the last video I'm making for this amplifier. Still have a few things left to do on it, but just elementary things that don't really pertain to what these videos are about. So, okay, so I ended up installing the vacuum relays. The SWR down to 1.4. The internal lead length of the relays causes 1.4 SWR. I'll show you here. 1.4. So it's plenty low enough. Start off with 3.6. Won't be adding any extra capacitance or any of that nonsense, or lead length, or any crazy whatever to get it down any lower. That's plenty low enough for any solid state exciter that he may use to drive this thing, or solid state transceiver. So I'll go over everything I did here. Camera off the tripod. Okay, so put in one single fixed resistor for the metering, 100 meg resistor. It's rated for 7.5 kV. He has 4,500 or so DC on the plate, so it's more than adequate. New properly wound plate choke. New output vacuum relay. RG393 for short, shielded lead length. Grounded on both sides. Here has an actual safety choke now. Proper flange. This is an old flange. It's been cut by someone else, but proper flange. Cut that to give me more clearance, even though it would have been fine. I cut it just for the heck of it. This capacitor, the test okay. It's kind of right on the cusp of what he needs for total capacitance to tune this thing up. It's right near max capacitance. He opted out of changing it, so for some reason the shaft has a pin through it, so he just wanted to leave it as is. I'm going to change the knob on it to give it more isolation. Shaft and knob phenolic. So this one, so you know, you have more voltage on the plate than the load. This sort of flash, now he's protected. Bushing, coupler, it's properly mounted. Like I said, I did not build this thing. I wasn't rebuilding it. I just did some stuff to it. I recommended a tube socket, different chimney, you know, down the road. I would have done some other things different. But, I mean, I could keep going and going, just putting more and more time into it. But, this will work just fine. With the proper bypass cap at the base of the plate choke, he had a weird doorknob cap, modified doorknob in use before with the Teflon choke, the Teflon wire wound choke that lacked enough total inductance to work properly. So I'm sure RF was getting past the choke, and that cap was running hot, the old cap. And I'm sure he had RF leakage making its way back to the cold end, which was causing the old cap to run hot. And I'm sure he had RF escaping the amplifier going back down to the power supply, and of course that wire wasn't shielded or anything. So okay, I ended up making an adapter plate for the new blower. So it's properly sealed, properly mounted. I have not plugged this hole yet. put a new grommet in. This is a Cooltronics high pressure blower. A new high voltage connection. Like I said before, he had the wire going through a grommet, which we can save putting a lot of stress on that old worn out capacitor. New SO239 connectors, silver plated Teflon type. Nice and tight now, center pin. Okay, so I'll stop this video and I'll show the bottom, and that'll be it. Okay, here's the bottom. I have not wired the new relays yet, the coils. So you have choke here. The biasing's controlled by this side of this relay. This side's no longer being used for anything. New input T-network with a vacuum variable. He has switches and knobs on the front. That's such a weird layout. I mean, normally I'd have the adjustment on the front, but I didn't want to make that look messy. I didn't want to alter the looks of the front panel, so I put in a right angle drive and have the input adjustment on the side. Like he had, where he had the old Pi network. Remember, one side, this side had the variable, I ended up putting the cap over here. I almost used that hole, but I said no, I'll just make a new hole. So put a feed-through bushing, quarter-inch bushing. Have a quarter-inch collar here, so if you push on it, it won't. It pushes on the bushing instead of, I mean, on the coupler. I mean, the coupler. I'm sorry, the collar pushes on the bushing instead of allowing the shaft to push in, put pressure on the capacitor. Have a phenolic shaft here. The coupler. That's what a bushing looks like. Quarter-inch bushing, panel bushing. So now when you adjust it, should be set and forget, but nice and smooth. Put in a standoff here to give some support to the back of the capacitor. So that's about it for that. RG142, I believe, Teflon. Grounded on either side. I'm going to add a delay, some sequencing to the relay, so the output engages first, and the input. I have a few other little things I'm going to do. Blower. No obstruction. You look this blower up online, almost 500 bucks. People, they skimp on parts because parts like these are so much less. No socket, I mean, like using washers and machine screws to hold the tube in, I mean, that costs, 20 cents or so versus the socket that costs, $300 or so. A regular blower, low pressure cruddy blower could cost 50 bucks, and like I said, a blower like this is about 500 bucks. I'm lucky to have tons of parts. I stockpile parts, so I get parts at a good deal when they're available, at good prices, and I pass the savings on to the customers, so I don't skimp out on parts. So you end up paying for it, or the customer ends up paying for it, and when I fix something or make something, I'd rather it never come back. I'd rather the person be happy and never have to be down and have to wait for a repair. So, little tiny vacuum for the input. Once again, the coil not wired yet. I'll plug up any little holes that in the RF deck floor to allow air to escape. I want as much volume to go through as possible. This blower is actually overkill for a single 3, but nothing wrong with overkill. So, use Teflon. This is Teflon wire, silver plated, stranded, center conductor, Teflon. This is Teflon, same thing. So, that's about it. This was more of a labor of love than anything. The owner's a good guy. The amplifier worked when he got it, but safety was a concern, and it would have, multiple things would have ended up failing. So now it should last a while. It should last a long time. So I'll show the front so you can see what I'm talking about. I would have had to have come in between one of these or above or below, and it would have looked funny. So, spinner knob. So, that's about it. I work on all sorts of different amplifiers. Any tube amplifier can repair, build from scratch, mono, multi, whatever. This is for educational purposes. Just like I said, I did not build this. I didn't rebuild it, I just repaired it, modified a few things, replaced, repaired. For a licensed ham radio operator, and that's about it. So, if anyone has any questions, give me a ring or drop me an email. I also have lots and lots of parts available. If I had to guess, I probably have more parts than all of the other people that do this combined. Parts, tubes, sockets, insulators, diodes, blowers, over 2,000 pounds of oil-filled capacitors, doorknob caps, whatever. I have hundreds of feet of RG393. I have a new coax that's rated for more than 393, more than twice the amount. So, feel free to give me a ring. That's it. Thanks for watching, and have a blessed day.